Hello, hello, hello. Welcome to my channel. This is the first ever video I'm putting up on YouTube. Let's hold for applause. Hope you're excited to jump right in and check out NSLOOKUP on a Windows PC. Trying to use it for troubleshooting DNS issues. I don't have DNS issues at the moment, but if I did, guess what I could use to troubleshoot them. So, here we have our wonderful command prompt. If you don't know how to open that, you're looking at the wrong video. In the nicest possible way, you need to go back a step. I don't even know why you're here. I don't even know why I'm making this video, but bottom line is open a command prompt and we will get started. It helps if it's administrative level, but it's not critical. So what is NSLOOKUP? NSLOOKUP is a tool that we can use to do public DNS lookups, private DNS lookups, and figure out what our machine or what a client machine is doing when it's trying to do DNS lookups. Why is this relevant? Well, DNS is the core, the backbone of the internet and a variety of other services, applications, and a variety of other things. If your computer wants to speak to another device or website or application on the web, chances are it's using DNS to do that. DNS at a fundamental level is a conversion of, well, as far as A records go, is a conversion of IP addresses to host names and vice versa. In another video, perhaps, depending on how this goes, I'll go through the different types of records, because there are different record types, which you probably know if you're here, but we'll go through some of that in more detail in another video. So right now, just trying to get an idea of how we can test on our computer, how we're accessing the internet, whether or not we have DNS issues, stuff like that. So at a fundamental level, you don't need to use NSLOOKUP. If you're just trying to find out the IP address of something, you could, in theory, just ping it. So arbor.com is my domain. If I ping it, comes back with an IPv6 address, which is stinking. Nobody likes IPv6. Nobody. I'm one of the naysayers. I completely understand why it's necessary, but nah, it sucks. So we don't care about IPv6, at least not now. I'm obviously getting a response because there is an IPv6 record for arbor.com, and my DNS server is probably defaulting to an IPv6 server, so we're getting an IPv6 response. If we want specifically an IPv4 response, then guess what? We can do the same thing, but at the end of the ping command, we can append hyphen or dash, depending on where you are in the world, 4 for IPv4. And we get a response. This looks more like what we're talking about. We have this 185.151.30.173, which is the web server where this site lives. So at a fundamental level, you don't even need to use NSLOOKUP to do DNS lookups, as long as you're looking for an A record for something. Equally, if we're looking for something, a subdomain of arbor.com, for example, I know that exists, we can see that csp.arbor.com comes back with a different IP address because it's a different A record. So very simple DNS lookups can be achieved via a ping command, but if you want to get into a little bit more and to check how your machine is resolving things, then NSLOOKUP's the way to go. Pardon me as I batter my recording station around here. So in order to get into NSLOOKUP, we can do it a few ways. Say we only want one sort of specific response. We could use NSLOOKUP space and then the host name that we're looking for. And that'll give us the default A record, or in this case AAAA, quadruple A, which is IPv6, response for that domain. So let's look at the way that the response is formed. We get this bit here which tells us which DNS server is doing our lookup, which will be the default on my network, which is probably my router. So this horrible, you can't really talk about this at a dinner party, can you? If you're sitting amongst nerds and you're talking about IP addressing, you're not going to talk about your IPv6 server that's like FD, Foxtrot Delta, Charlie 7. No chance. Anyway, this is the server that's giving us our response, that's doing the lookup and providing us with a response. We then have this bit here, non-authoritative answer, which is kind of an interesting bit of information, not hugely critical, certainly not at this point in the game, but it tells us that the response that this server has given us is not necessarily the truth. It's not, etched in stone. The reason for that is because this server is not the authoritative server responsible for holding the records for arbor.com. What does that mean? Typically with a web server, for example, or a domain that's hosted on the internet, you have name servers. You've probably heard of them. You need to change name servers if you're looking at using a different hosting company sometimes. That's a very simple look at it. If that's the case, then that name server is the authoritative server for that host name. So in this case, arbor.com is not hosted on this IPv6 address that lives on my private LAN. So let's use NSLOOKUP to find out a little bit more about this domain and see if we can find what authoritative server it would be. So what we can do is we want to just open up the NSLOOKUP tool by itself without specifying any parameters, and we will get into a sort of new command line that we can enter in host names. And in this point we can type in arbor.com, get the same response. Okay. What if we want to find out the name servers of that domain? Not just the A record or quadruple A record, but we want the name servers, the meat. Well, we can do set space type equals, and you said name server. No, it's just NS. So when you're talking about DNS records, typically they are acronyms or very shortened. So NS, MX, A, CNAME, TXT. If we do set space type equals NS, all of a sudden we get a response with a blank prompt, but if we type in arbor.com, we get a list of name servers. For this particular domain, there are 4 name servers, which is pretty handy. Let's go ahead and grab just the first one, so NS1. Typically name servers are named in the same sort of fashion, NS1, 2, 3, 4. So let's grab that one. On a Windows 10 machine, kind of nice in command prompt, you can highlight whatever you want with your left mouse button, hit enter on your keyboard, and all of a sudden it's on your clipboard. Pardon me. Brain fart. So let's leave the NSLOOKUP tool again just by typing in quit. And when we get back to the command prompt, let's now try and test a lookup directly to that name server. So NSLOOKUP also gives us the ability to do direct lookups to a DNS server that isn't our default. So instead of having to muck about in Windows, going through your network control panel and adjusting the settings on your network adapter so that your primary DNS server is now Google or whatever, you can use the NSLOOKUP tool to do that lookup for you without having to change your NIC and readjust things that way. So the way we do that is, instead of, if you remember a little while ago, we did NSLOOKUP space arbor.com. That's saying do an NSLOOKUP for this host name, provide me with a response. If we want to say do a lookup but use the following server, we can use a hyphen or dash depending on where you're at, and then we put in the name of the server that we want to use as a lookup. So my machine is a DNS client, and I'm going to speak to a DNS server to get a response and bring that back. That server is going to be, in this case, ns1.stackdns.com. So you'll see this all of a sudden is different from what we've been seeing already, because we've specified a new name server or DNS server. So at this point I can, as long as they allow public lookups, I can say give me a response for arbor.com. Notice we don't get this non-authoritative answer anymore. It's all blank. And because of that, we can assume that this is the authoritative server, which is kind of nice. So we get a response that tells us what's going on. Equally, going back a step, quite often in DNS troubleshooting we want to specify a different DNS server for our troubleshooting. So quite often if there's going to be a DNS client issue, and in simple terms, one person's PC isn't able to access the internet but other people are, then we want to see what DNS server their network card is using, and we want to troubleshoot that connection by using NSLOOKUP, and if that fails we want to use a different server for testing. But if you're working on that remotely, maybe you don't want to change the network card settings because maybe you lose your connection and maybe they're halfway around the world and that's a problem. So in this case we could specify an alternative DNS server that we want to use for lookups. In this case 8.8.8.8, super catchy, which is Google's public DNS server or primary. We get a response, dns.google. Address 8.8.8.8. Kind of sounds like a little tune. And here we can, give it whatever we want. Again, we see that non-authoritative answer because they don't host the nhl.com domain. Fire another couple in there. Look at that. That's kind of interesting. So BBC comes back with a few different records for A records and for quadruple A records. The most likely reason for that is that they are hosting their website on a number of load balancers or something. So this is more for a web surfing and resiliency setup than inside you would have maybe one machine on one IP address, so you have one record for it. But this is something where if we go back, we said we could use ping for very simple lookups. If we were to ping bbc.co.uk, we only get one response. How do we get an IPv4 response? Do you remember? The guy over there in Chicago got it. So -4, and we get a response that 151.101.081. We can see it is on the list, but we don't get a comprehensive list, whereas with NSLOOKUP we do get that list. Which is quite handy. So a lot of these records you can get online using specific websites and stuff like that that have an API that goes off and does a lookup, but it's quite nice to be able to do these lookups from a client machine itself, because then you're testing DNS functionality on that machine. It's also important to note that if you were to hack your host's file, for example, then you can end up in a situation where you're resolving things incorrectly on that machine versus how you would publicly. I can potentially do another video on that if somebody's interested, but the bottom line is that NSLOOKUP is a great tool for just finding out how your machine is trying to resolve things, and based on that it gives you a kind of plan of action for what to do. One last kind of option here would be when we're running the NSLOOKUP tool. If you use set space debug, it doesn't really change anything. But at this point, if you give it a domain name, it'll come back and it'll give you kind of the steps that it took specifically to go off and find a response for you. So it goes through each individual sort of question and answer. This answer is for arbor.com.home. So I'm willing to bet that in my network card handed out from my router via DHCP, it appends a domain suffix of .home, which is probably somewhat traditional. So my machine is going and querying arbor.com.home because it's the primary DNS suffix on my domain. It comes back and says effectively there is no response. That is that one there. So it then goes through, that's a type A query, so just a normal A record. Here's a quadruple A record query for the same thing. Comes back saying nope, doesn't exist. It then goes off and does a lookup for just the root domain. You'll see that's different from .home. For type A, which is an IPv4 address, this comes back and says no error, and then responds with the answer the 185 address, which is quite nice. The non-authoritative answer for the quadruple A for arbor.com is the following as well. So if you want like a very verbose output of what your machine is doing when it's going off and doing these lookups, then that's quite a nice way to do it. You'll kind of be aware if you're paying attention that in order to get a response, my machine has to do 4 queries in effect for arbor.com, and it comes back and tells me that the IPv4 and IPv6 for arbor.com.home, which is my primary DNS suffix, doesn't exist. Then it defaults to the root domain itself. If you are quite clear on what you're looking for, you could append a full stop or a period at the end of your query, and it'll come back. And it'll only do the 2 lookups, and that full stop is because it effectively terminates the host name. So it specifies that it's not going to try and append the primary DNS suffix. If I quit out of this and do an ipconfig all, oh god, there's a lot going on here. Let's find the relevant one. Here we are. So in this wireless adapter, which is the one that I'm currently using, we have connection specific DNS suffix, which is home, which means my machine is technically mycomputer.home. And it's got an IPv6 address, and it's got an IPv4 address, and it's got DNS servers for both. And Windows 10 by default uses IPv6 first. You can modify that and make some changes to it, but again, that's out with the scope of this video. So that hopefully gives you a little bit of an insight into how to use NSLOOKUP for troubleshooting. It's kind of hard when there isn't a genuine issue to troubleshoot. Can kind of simulate it here. If we were to use like a random server that doesn't exist and say go and do lookups from this, this might be the kind of behavior that you're seeing on a Windows 10 machine that is having DNS issues. So if you were just to do NSLOOKUP on a machine having issues and it comes back saying DNS request timed out, that's a pretty good indication that the primary DNS server, potentially the secondary DNS server, if you've got more than 2, it's a good indication that some of those things aren't working. So in a domain environment where you've got one domain controller serving DNS, you may want to test other machines to see if they're having lookup issues. We can see here if I did domain.local, I get this little moment where it times out again, times out again, times out again. So it's going through that process of doing those 4 lookups, and it's coming back with those timeouts. If you had a domain environment where you maybe have 2 DNS servers, you maybe want to specify the alternate DNS server in order to do some testing. So we could, if we had a DNS server on 110, and all of a sudden if this came back and gave us responses, then chances are 111, which is the first server that we were using, is having some issues serving DNS responses to people. So again, getting other machines to test DNS resolution via that server gives you a better picture of what's going on with DNS. Equally, the same can be applied to internet-facing DNS servers. So if you're doing these lookups and you're getting no responses, it could be an indicator that maybe your ISP's DNS forwarders are incorrect, and then you want to start doing these types of tests on your domain controller to see how it's performing and doing its lookups. Again, I can go into that in a different video if people think it's helpful, but in any case, that's really what I wanted to cover today, just a very, very broad strokes overview of how to use NSLOOKUP to troubleshoot DNS errors. Very difficult to do when there isn't an error, there isn't a specific problem going on just now to troubleshoot, but it gives you a good picture as to how you might do that should there be proper DNS issues. So thank you very much for spending the time checking it out. If you found this helpful, give me a thumbs up, drop a comment. if you'd like to see anything else that is similar to this, I'm hoping to do more videos like this and spend some time sort of providing a bit of insight into what it's like supporting IT and trying to do some troubleshooting. So if there's anything specific you want to see, drop it in the comments, and thank you very much for taking the time to watch today. Enjoy the rest of your day.